we're going to apply our graphing, equation, and inequality skills here to absolute value functions. Remember, the absolute value makes everything positive. So what that means, okay, is our graph will be V-shaped. It's a V-shaped graph, especially as we look at y is equal to the absolute value of x. That will always look like this. That is the graph of y is equal to the absolute value of x. It's a V-shaped graph. V-shaped graph. In this case, this red point here is called the vertex. So every absolute value function will have a vertex, a single point where both rays come to meet. In this case, it just happens to be the origin. Now, what we're going to look at here are shifts in this graph. And what we always want to refer back to is this vertex. Because if this vertex shifts to the right 4 and down 3, then everything else is going to shift to the right 4 and down 3. All of that will still happen. We'll make this wider. We'll make this skinnier. We'll also make it open downwards. Okay, those things will all happen here in these different examples and different types of graphs that we'll have to do. So let's take a look at this. And again, I'm going to put the that is y is equal to the absolute value of x. So everything is compared to that. Now with these, you may want to do a t-table. If we look here, when an xy table, in this case right here, when x is 1, y will be -2. When x is -1, y will also be -2, because the absolute value of -1 is 1 times -2 gets us -2. And then I'll come back to 0, and we'll still get 0. So I have 3 points I can graph. Our origin's still the same. We have not shifted that at all. I have 1, -2. I have -1 and -2. So obviously that's flipped, and it looks to be a little bit skinnier. A little bit skinnier. I'm going to do this one as well in blue. Let's do xy again. Let's start at 2, -2, and 0. When x is 2, this will become 1. I'm sorry, it'll become -1. I jumped down 1. -1/2 times 2 is -1. When x is -2, again, it'll be -1/2. And times +2, we get -1. And again, we have 0, 0. So we have our points. Still 0, 0. But now we go 1, 2, and -1. 1, 2, and -1. And that one appears to be wider, and it still opens down. The reason these two open down is the coefficient is negative. The coefficient of a negative makes this open downwards. If we look at the other two graphs, they're going to be the same except with positive. So if we look at 1/2 x, and we do 2, -2, and 0, we'll just get 1, 1, and 0. And you can plug those in if you don't believe me, but that is what we'll get. So again, we're 0, 0. We go 2, 1 right there, and -2, 1. And as you can see, those two with the fractions, okay, between -1 and +1, those made it wider. You can really see it in this red graph because it's right compared right underneath the absolute value of x. Those fractions like that will make these wider. Okay, and as we look at this last one, we'll end up with the same 1, 2, negative 1, 2, and then 0, 0. So 0, 0, 1, 2 is there, negative 1, 2 is there. And as you can see, these 2's, whole numbers greater than 1, less than negative 1, make these graphs skinnier. And that will be the case for all of these. Another graph here, thing to try. And again, we're going to start with the absolute value of x there, and we'll just have that be our black line graph there. Let's take a look here. Again, we're going to use a t-table for this first one. X minus a negative 2. So let's make x, let's start at 0. 0 minus a negative 2 is 0 plus 2. That's going to be positive 2. Okay. Let's make x negative 1. Negative 1 minus a negative 2, that's negative 1 plus 2, we're going to have 1. And let's go to positive 1. 1 minus negative 2 will actually give us 3 there. Let's go to negative 2. Negative 2 minus negative 2 will actually give us 0. I probably should have started there. So we plot these points. Negative 2, 0. Negative 1, 1. 0, 2, 1, 3. I need to go at least one to the left here. Negative 3 will actually end up giving us positive 1. So that'll be right there. So that graph shifted left. And what you'll normally see that written as is y is equal to the absolute value of x plus 2. This shifts left 2. Now, I know we're going to see plus, and we're going to think we want to shift it to the right. If it's on the inside, you think the opposite. X minus 0 is just x, so that is our original function there. Let's take a look at absolute value of x minus 2. And I'll be a little more specific here with our samples. I'm going to do 3, 2, and 1. When x is 2, we do get 0. When x is 3, 3 minus 2 is 1. The absolute value of 1 is 1. When x is 1, 1 minus 2 is negative 1. The absolute value of negative 1 is 1. So I have my 3 points here. I have 2, 0. I have 3, 1, and 1, 1. So we'll see this graph shift to the right. Okay, and again, that's minus there. It's going to be opposite. That minus, typically we would think left, but it's on the inside, so we will shift to the right with this. And last part of our activity here, we'll start here. Again, the absolute value of x plus 0. If you add 0, you don't change it. So that is just the original function that we can compare to here. We're still comparing to that. And let's take the absolute value of x minus 2. So let's just do negative 2, 0, and 2. The absolute value of negative 2 is 2, minus 2 is 0. Absolute value of 0 is 0, minus 2 is negative 2. Absolute value of 2 is 2, minus 2 is 0. So negative 2, 0, 0, negative 2, 2, 0. So what that did was it shifted us down 2. So the minus on the outside does go what you normally would think. Minus is going to move us down the y-axis, so that will shift us down 2. Knowing that, we should probably be able to deduct that this will shift us up 2, which it will. Let's just use the same, -2, 0, 2. -2, absolute value of that is 2, plus 2 is 4. Absolute value of 0 is 0, plus 2 is 2. Absolute value of 2 is 2, plus 2 is 4. So again, I have my 3 points. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. And again, that did shift us up 2. One example here, as we take a look at this, and then I'll shut this video down early. You probably won't fill in every spot. We'll finish it tomorrow during class, though. But I do want you to see one example. Let's go ahead and take a look at this one. Again, we want to think about that vertex. This will shift us left 2, up 3. So that's my vertex point. Left 2, up, left 1, 2, and then up 1, 2, 3. So there's my new vertex. Now, I have a negative out front. It's going to flip it and open it downward. I don't have a fraction. I don't have a whole number. It's not going to be wider or narrower. So it's going to just go down, down 1 left 1 and down 1 right 1. We're going to go like this. And we'll get into the specifics tomorrow as far as how you can tell what the quote-unquote slope of these are. Again, we'll pick up with this tomorrow. You probably will not be able to finish your note sheet based on this, but we'll finish that tomorrow during class. Still do your questions, still do your comments, and we'll pick up with those tomorrow.